Hi, I'm John Graves, and in this podcast, we're going to deal with the second half of the Asking Questions in Science and Defining Problems in Engineering, Science and Engineering Practice. As always, I will remind you to take a look at the Conceptual Change Cycle model that is linked below in the video description. This allows us to determine where we are in this conceptual change process. As teachers of science, as we work through the science and engineering practices, it's important that we begin to understand our own conceptual change around each of the practices so that we can assist our students as they also work through that conceptual understanding of each of the practices. I always will direct you to the framework book for the particular practice that I'm talking about. So you may want to pause the video and get out your framework book and look specifically at what's written about defining problems in engineering. It's in the Asking Questions in Science and Defining Problems in Engineering section. If you don't have a hard copy of the book, there is a PDF link that is listed in the video description below. As you are going through that reading, I will encourage you to take a look at the verbs that are listed in that description and ask yourself, what are students expected to do when defining problems in engineering? It's best if you put those verbs actually on a page, write them down someplace, and if you have the ability to communicate, talk, and interact with a colleague, this is a great place to carry on that conversation. Once you've taken a look at the verbs and you know what students are expected to do the same thing with the nouns. What are students expected to produce when defining problems in engineering? When I think about engineering, I see it as a process that helps us as humans solve problems. That's a pretty simple statement, but I think it encapsulates the whole notion of engineering. So whether we're talking about mechanical things or biological systems, if we have a problem as a human race and even as individual humans, and we want to solve that problem, that's what engineering is all about. So let me present to you a human challenge. And that challenge is this. I'm challenging you to take a single Pringles potato chip, package it somehow, and mail it to me at my house in Bozeman, Montana. Okay? As we think about this practice of defining problems in engineering, that's what we need to do now. We need to define what this problem is. We've defined this engineering problem, and that is you need to mail a single Pringles potato chip to my house in Bozeman. But there are limitations around that problem that I'm going to give you. In engineering, we call those constraints. Those constraints include the fact that this needs to be a single potato chip. It's in a letter-sized envelope. You are limited to the supplies of paper, tape, string, and cotton balls, and there's to be no commercially made packaging at all. So not only have we defined the problem, but we've also identified the constraints or the limitations that go with that problem. Engineers face constraints all the time when they are defining their problems. Those constraints include things like materials, time, money, just maybe the location of where something is. There are just numerous constraints that have to be identified that is part of the defining the problem process. This practice is around defining the problem. But you can see we can define the problem fairly quickly in many circumstances. So it's often a very quick move from one science and engineering practice, in this case to defining problems, to another science and engineering practice, which I'll talk about in a different podcast, but in this case it would be solving a problem. So oftentimes there's a very quick, smooth transition between science and engineering practices, but for now we're only talking about defining the problem. So once you've written that problem down, and you've got it succinctly on paper in your mind, you can easily then move to the solution stage of taking care of this problem. So as you think about this, I challenge you to reinterpret your beliefs around this particular practice. So how did that brief description of the Pringles Potato Chip Challenge change your beliefs about the practice of defining problems in engineering? Is there a way that you can think about fostering this understanding for your students? And then how can you make this practice a part of every learner's repertoire. And again, I encourage you to carry on these conversations with colleagues if you have that opportunity. This is also a really good place for me to talk about the interconnectedness of practices. As I mentioned just a moment ago, it's a fairly smooth, easy transition to get from defining a problem in engineering to actually solving that problem. So as we think about the science and engineering practices, although they are presented in these podcasts and often in the literature as isolated practices, we need to begin to think about the interconnectedness of all of the practices. And I will remind you of this in future podcasts as well. The toolkit for teacher conceptual change deals with the practice of defining problems in engineering. And in addition to the Pringles challenge, there's another activity. If you would like to take a look at that toolkit, it's linked in the video description below. I will always encourage you to refer back to the conceptual change model and see where you are on the conceptual change cycle relative to each of the practices that you encounter. And in addition to that, I will also encourage you to do the self-assessments for each of the science and engineering practices as you encounter them. Both the links to the conceptual change model and these assessments are listed in the video description below. Thank you.